This presentation is one of a series dealing with cargo operations on board an oil tanker. In this module, we deal with the task of heating the cargo to maintain its temperature. We're on our way to Europe from West Africa. It's winter, and the vessel has received orders to heat the cargo to maintain the loading temperature. Our vessel has 7 cargo tanks and 5 permanent ballast tanks. There are 2 slop tanks directly aft of cargo tank number 7. All cargo tanks and the slop tanks are filled with crude oil. Our vessel has no double bottom. To heat cargo, there are heating coils in the bottom of all cargo tanks. On this ship, there are 12 coils in cargo tank number 1, 14 coils in each of the other cargo tanks, and each slop tank has 6 heating coils. To describe the principle of heating cargo, we show one coil connected to a simplified heating manifold. This is how it works. Steam is produced by the boiler and is passed to the main heating line on deck via a pressure control valve. From this line, it is passed to heating manifolds, which serve all individual coils in each cargo tank. You will get the best heating when the steam condenses to water in the horizontal part of the coil. Here the steam cools below its evaporation point and condenses back to water, the heat being absorbed by the oil around the coils. As oil is a poor conductor, heat is mainly distributed by convection currents set up within the tanks. Depending on the pressure in the coils, the temperature of the steam will be between 110 and 165 degrees centigrade. This particular system is built to work with a maximum pressure of 10 kilograms per square centimetre. The steam trap allows only water to return to the main return line. There is also a drain cock and a filter on every return line. The condensed water is passed back to the boiler through a filter, which has an automatic alarm for oil, and then through a hot well tank. This is to ensure that no oil is returned to the boiler. Oil reaching the boiler can create a very dangerous situation. The temperatures in our tanks are falling. It is time to activate coils. Starting up the heating will probably take you most of a working day. It's important to take your time to warm the main steam line properly. If this long line is fed too much steam, it will cause strain. The main steam line may break, and you cannot heat the cargo until the line is repaired. So it's a good idea to first use the bypass valve when warming the main steam line. To proceed, first you should drain the line of water through the drain cocks. Leave them open. Now you may ask the engine room to warm the steam line. It can take several hours to heat the line, so be patient. Do not rush. Close the drain cocks one by one when steam is coming through them. The next step is the most laborious one. All coils must be checked for leaks and traces of oil. Water must be circulated through every coil and passed to deck via the drain cocks. The entire length of the coils must be flushed through. This will take some time. Consider the volume of a coil and measure the amount of water passing through the drain cock per minute. It is not enough to flush a coil for 10 to 15 minutes. You can probably flush several coils at the same time, but supervision, checking for traces of oil, is difficult, especially at night. There's plenty of room for innovations. This is one way. Empty, cut-up drums with U-pipe drains are used as buffers. This way you have more time to inspect the water. If there is oil in the water, the coil may be leaking. The coil must be closed and sealed, then tested and repaired at a suitable time. Oil must not be allowed to return to the boiler. When the heating is started, cargo temperature should be taken in the morning and evening. All important data is recorded in the heating log. Date, morning temperatures of seawater and air, relative wind direction, and the state of the sea. Pressure and time of changes along the steam pressure line are noted. And here you note morning and evening cargo temperatures. Also note the number of activated coils in the tank. Here are the temperatures of the return water in the morning and in the evening. There is also an entry for fuel consumption. Remember, the ship's cargo tanks are insulated from the passing seawater on their sides by the ballast tanks, but the bottom is cooled by the sea and the deck is cooled by the wind and sea spray. Now the temperature is falling and it's time to activate the coils. The inlet valve is fully opened and the return valve is partly opened at first. After a while, when water is flowing through the return drain, the return valve is fully opened and the return drain is closed. Observe that the inlet valve should be fully open. The normal position of the valves is either fully open or closed. You should regulate the heating by the number of coils activated and the main steam pressure. If you need to manipulate the flow, always use the return valve. To observe the system's response to your different actions, measure the temperature of the return water. You should always try to keep the intended temperature, using as few coils as possible and with lowest possible steam pressure. If the temperature is generally falling in the tanks, activate more heating coils or increase the steam pressure. If the temperature is still falling with all coils active, increase further the steam pressure. If the temperature generally tends to rise in the tanks, close coils or reduce the steam pressure. If the temperature in a separate tank differs from the rest, open or close heating coils. The forward tanks are always harder to heat than the aft tanks. Towards the end of the trip, with all coils activated and heating at maximum capacity, you may have to close coils in the aft cargo tanks to direct more steam forward. Remember, heating cargo is easier in sheltered waters. During discharge, the heating should be stopped before the coils are exposed. Close the inlet valve first. Do not close the inlet and the outlet valves at the same time. If this is done, an underpressure will develop in the coil when steam turns back to water. Oil may, one way or another, sneak into the coil, giving a false indication of a leaking coil. Keep the return drain cock open and you will avoid such underpressure. In a crude oil carrier, there is one simple way to maintain and control the vessel's heating system. Keep the heating coils completely filled with fresh water when they're not in use. However, there is one exception. If there is a risk of freezing temperatures, empty the whole system of water by blowing through with air. Note that fresh water expands when the temperature begins to fall below 4 degrees centigrade. At 0 degrees centigrade, it turns to ice. If ice blocks the expanding water, the coil will break. Turning back to normal maintenance, always be on guard for leaky and faulty coils. Take every opportunity to test them. This can be done by pressurizing the main steam line with air. Open the drains and then the inlet valves one by one. If water comes flowing relatively quickly through the return drain, this indicates a healthy coil. If there is no water flow, or less than expected, or even oil flows, you probably have a leaking coil. If there is a leak in a fully loaded tank and the return drain cock is opened, water, propelled by the inert gas pressure, will start to flow to deck. If there is a leak on a coil in an empty tank, the water will leak into the tank. An empty coil means trouble. Keep in mind that the coils are the weak link in this system. Check them every trip, or at least once a month. Checking the coils with air is fast and easy. Every 6 months, the heating coil should be properly tested with water pressure. Do not just ignore the heating system during periods when cargoes are not heated. It is a vulnerable system and needs your attention to function on the day you need it.